Good morning everybody. So today we are going to solve the problem partition labels of Leetcode. So let's understand the problem. So you're given a string S. You want to partition the string into as many parts as possible so that each letter appears in at most one part. So let's go through the example. The first example is this string. So this is the string, and the solution is 9, 7 and 8. And why is this a solution? Because based on the question, we have to partition this string such that all the letters, all the occurrence of some particular letter needs to be in the same partition. So if we start with this A, which is the first letter of our partition, it should extend at least up to this A, because the same letter cannot be in a different partition. So we have to extend the partition in such a way that all the letters that falls into this partition should fall only in this partition based on the question. So 1 2 3 4 5 6 7 8 9. So looks like all the other letters also are only in this partition. So there is no B in any other partition, there is no C in any like outside of this partition, B A C A. So this is the first partition, which is 1 2 3 4 5 6 9, and then the next partition starts from here and it goes 7, the length of 7. For example, 1 2 3 4 5 6 7. So looks like this is the partition because any occurrence of D is inside this partition, it's not outside this partition. E follows the same thing, there are 3 occurrences of E. F follows the same. G, there is only 1 occurrence of G. D, same thing in E. So this is the second partition, and if you this is the start of the third partition. If you go on checking H, so this is the next partition of H, so it should extend at least here. And if you see I, this is the next occurrence of I, so this partition should be at least here. J, this is the last partition, so this is the partition. So how do we do it, right? So you understood the question. The question says you want to partition the string into as many parts as possible so that each letter appears in at most one partition, right? So each letter should appear in at most one partition, it should not appear across partitions. So this is the solution. So let's jump into the solution. So for solution, we just saw that when we start with some starting point, right? We need to start from some starting point. We can say A, and then we need to check the last occurrence of this particular partition, which is, let's say, some pointer. Let's call it last, right? So this is the start, and we immediately can check whether this is the last occurrence of this or not. If it is not the last occurrence of the partition, we need to check all these elements between this start and last, right? And if any of these occurs outside this last, we need to extend our partition to include that number as well. And then if after that, if we find a situation where start is equals to that means let's call this element I. So I will start from start to this element, and at some particular point, if I is equals to last, that means all these elements are only in this partition. So we need a way to memorize the last occurrence of each letter in this string. So we can use a map for that. Right, so once we go through the map will remember the character and its corresponding last occurrence, right? So then we go through each and every character and keep updating the start and the last index, and at some particular point of time, if we find that I is equals to last, that means we have got the solution. Let's see in the code.
So if yes is less than 1, then we can just return an empty array. Now for capturing the last index of each character, let's create an array and let's go through the string once and capture the index of each and every character. Now that we've captured the last index of each and every character, let's start our logic where we have two variables, start and end, and then we'll start with the first character of the partition and keep on expanding our partition, and as soon as we made a condition where the partition could be ended, we will capture that length and put it in an array, and then finally return the array. So yeah, as you can see, this start is the starting position of the current partition. This is the end index which will be updated. So as soon as we encounter a character, we will check the last index of that character, which is this value, and then we will take the maximum of the current end and this value, because that's the maximum value is where the current partition will end. And if I is equals to the end of the current partition, that means the current partition has ended and we can start with a new partition. So we'll capture the length of the current partition and then point our variables to the next index and start all over again. And finally we return the answer. So let's see if it is correct. Okay, so this works for this solution. Right. So thank you guys for watching. See you guys in the next video.